Welcome to this presentation of a curriculum review of the College Preparatory Math course, Core Connections ALgebra. This curricular review is completed by me, Michael Paul, a doctoral student at Florida State University. F. James Rutherford, author of Science for All and Project 2061, writes, "Theoretical mathematics, unlike the other sciences, is not constrained by the real world, but in the long run contributes to a better understanding of that world." Today, we will look at the way in which College Preparatory Math Core Connections ALgebra helps to prepare students to have a better understanding of the world around them. The Core Connections series from College Preparatory Math, heretofore called CPM, is a problem-based approach that is student-centered. It focuses on structured collaboration, student discourse, and what they refer to as non-routine and team-worthy problems requiring strategic problem solving. This is from their website, cpm.org, published in 2021. In addition to the student text and teacher editions, there are standards alignment documents and student and parent resources provided in both English and Spanish, including online homework help, student resource pages containing fluency exercises with answers, a parent guide that includes condensed instruction with extra practice, and e-tools and video resources that are available online. Furthermore, there is a comprehensive teacher assessment handbook that includes extensive supports for both summative and formative assessments that are provided to teachers in the teacher resource CD that's given to schools when they adopt the curriculum. In addition to having instructions and problem banks for both individual and group tests, it also has recommendations for how teachers should approach the construction of tests and how they should approach the scoring of class tests. It includes a variety of ideas for scoring, including actual sample rubrics and advice on how to convert rubric scores to grades in a traditional grading system. Furthermore, it contains resources on student presentations of a variety of types and written presentations that include summaries, growth over time problems, reflection prompts, and journals. Furthermore, there is support for student portfolios that includes both questions that you might pose to students so that they can formulate a portfolio for this course, but it also contains answers to those questions, as well as a portfolio menu and advice on assessing portfolios. It provides guidance on end-of-the-year assessment that goes beyond traditional paper and pencil tests and includes several different growth over time problems and a generic rubric that can be used for assessing end-of-the-year items, as well as problem-specific sample rubrics. In addition to that, there are multiple supports that are included for success in instruction, including how teachers might pose higher level questions to groups as they work, toolkits, which are resource pages students complete that include formulas, definitions, and procedures for solving problems, the philosophy on homework, actually multiple philosophies on homework, the concept of revision and allowing students to improve their own work, and ideas for student self and peer assessment. Finally, there are rich tasks that include problem-based learning problems, investigations, and projects that students might complete over the course of the class Core Connections ALgebra. In order to evaluate the CPM Core Connections ALgebra curriculum, I will be using the CCSSO Mathematics Curriculum Materials Analysis Project. This tool was developed with input from NCTM, the National Council of Teachers of Mathematics, as well as the National Council of Supervisors of Mathematics. And it uses the Common Core State Standards of Mathematics as the guide to evaluate curriculum materials. There are three tools provided by CCSM in order to, there are three tools provided by the National Council of Supervisors of Mathematics in order to determine the extent to which a curriculum adequately covers the Common Core State Standards of Mathematics. Tool number 1 evaluates the extent to which the domains of mathematics topics are incorporated appropriately across grade band curriculum materials. The second tool evaluates the standards for mathematical practice and the extent to which they're embedded and integrated into the curricular materials. Tool 3 evaluates equitable teaching practices, assessment, and technology, and the extent to which they are addressed in the curricular materials. The first tool covers mathematical content. It has 2 separate rubrics that are used to evaluate the text. The first is coverage. That's the degree to which the curricular materials attend to the content of a particular standard. The second is balance. In this consideration, we weigh the degree to which the math content is balanced between mathematical understanding and procedural skills in ways that are consistent with the standard. For Tool 1 analysis, I first located the evidence of the standards in the curricular materials, noting the location by page numbers in the first column labeled chapter pages, beside the standards. I then recorded my judgments regarding the content coverage and balance rubrics. I focused only on the teacher and student books for this part of the analysis and not any supporting materials, as NCTM and NCSM advise that an acceptable curriculum should cover all standards within the primary text without relying on ancillary supports to teach the standards. Throughout the review process, I made notes of evidence that supported my judgment and wrote down key examples of what I found during the content analysis so that I could refer to them during my analysis using Tool 2. Using these ratings, I found the following strengths of content coverage. CPM Core Connections ALgebra provided excellent coverage of mathematical content, while the analysis of the teacher and student text provided ample conceptual content to develop mastery. For places where referring to the ancillary materials was the only way to reach a score of high in the balance category. Had the ancillaries been included in the rating, all indicators would have been rated a score of H for high. The weaknesses of content coverage include one potential problem with the curriculum. Not all teachers are equally motivated to dip into text supplements. The amazing depth and breadth of supplemental materials may be intimidating for teachers who rely on going problem by problem through text materials rather than considering the text a menu of options. If teachers tried to teach every problem presented in the teacher and student texts, they may fail to cover all of the standards in the course. This is a sample excerpt from the Tool 1 analysis. I examined each domain of the CCSSM, the Common Core State Standards of Mathematics, that is, and identified places in the student and teacher text where the standards were addressed. I looked to see if the content was covered in depth and meaningfully, as well as whether there was a balance between conceptual understanding and procedural fluency. This page shows one such analysis. I found the CCSM content to be fully formed in the Core Connections ALgebra text. Problems were scaffolded from highly accessible entry-level problems to deep-thinking performance tasks in the assessment handbook. For example, there were growth over time problems, collaborative games, rich tasks like the Big E growing functions problem, in which students take a series of growing letters and look at how changes made to those letters occur as you continue to add blocks in a sequence of block patterns. There was additionally lots of fluency practice for all topics. In addition, the Math Notes section builds meaningful understanding of the procedures, though these resources are limited to spiral review in the text and to ancillary resources. The second tool that I used to evaluate the College Preparatory Math Core Connections ALgebra text was Tool 2, Mathematical Practices. These are called SMPs for Standards of Mathematical Practice. The SMPs describe the types of skills math teachers should seek to develop in their students. They do not address content, but address the behaviors to reinforce in all levels of the math classroom. The practices describe what it means to really do mathematics, rather than just know mathematics. Mathematical practices in Tool 2 have been organized into one possible configuration in the NCSM tool: overarching habits of mind, reasoning and explaining, modeling and using tools, and seeing structure and generalizing. The practices are not necessarily discrete, and other structures may be possible. This is just one way. One example or task may not fit or may fit under multiple mathematical practices, and they should be recorded in each. The process The process used in reviewing the text involved reviewing a collection of a subset of content standards from Tool 1. These content standards were chosen as a basis for reviewing the mathematical practices because the developers of the CCSM and NCTM agreed that they had great potential to incorporate the mathematical practices in the curricular materials. The key standards identified for a high school algebra course included, but are not limited to, solving quadratic equations in one variable, solving systems of linear equations, explaining the connections between the intersections of functions f of x and g of x on a graph, and the solution to the equation f of x equals g of x. It also included finding solutions to f of x equals g of x using different tools. And in this case, the two different functions, f of x and g of x, could be any combination of linear, polynomial, rational, absolute value, or exponential functions. They also included using statistics to describe and compare two or more data sets, representing bivariate data using linear modeling techniques, application of the Pythagorean theorem, and extensive treatment of solving linear equations and analyzing linear functions. These are the results of the Tool 2 ratings for Core Connections Algebra. For overarching habits of mind, reasoning and explaining, modeling and using tools, and seeing structure and generalizing. Some of the strengths of the math practices were that all of the SMPs were embedded meaningfully into the Common Core Connections algebra text. The curriculum provided extensive support for teachers and students in making continuous use of SMPs in a meaningful manner. Some of the weaknesses of the math practices include the fact that the ratings of marginal for SMP 1 and 7 were not due to a lack of meaningful inclusion, but rather because the text relies overly much on scaffolding to take students from entry level through high cognitive burden problems. Once the scaffolding is removed, struggling students may not have the independent problem-solving skills to persevere on their own. Similarly, because the text tends to lead students to desired conclusions, students may not develop fully independent ability to make use of structure to solve problems that arise in novel contexts. This is an example or a sample excerpt from one page of my Tool 2 analysis. Using Tool 2, I considered how the SMPs were addressed one domain at a time. This excerpt covers 4 of the SMPs within the reasoning and reasoning with equations and inequalities, A-REI domain. I found strong evidence that the SMPs are embedded in the CPM Core Connections curriculum. Considering the overarching habits of mind, and especially focusing on SMP 1, make sense of problems and perseverance in solving them, structured problems help students to develop their own strategies for solving problems and encourage them to make toolkits which can be used to support ongoing mastery. With regards to attending to precision, the Core Connections text allowed students to critique work that contains students critique work that contains errors, and they cross-check their solutions by substituting them back in variables for the equations. They also compare their predictions from models to actual observations. For the reasoning and explaining section, SMP2, reason abstractly and quantitatively, my findings were that the text guides students to develop numerical arguments to justify solutions, to determine multiple representations of algebraic relationships, and to consider in-behavior and asymptotic behavior at early stages of development appropriate for a high school course. For construct viable arguments and critiquing the reasoning of others, I found that this was perhaps the strongest SMP for the curriculum. The program embeds explanation into every task with structured prompts for math writing, peer editing, collaborative discussion, portfolio and summary entries to justify and explain, and many presentations of fair learning throughout. There has been an ongoing effort in mathematics education reform to expand access to advanced mathematical content and to provide equitable instruction that reduces bias and prevents the marginalization of females and minoritized students, as well as English language learning students, from what has traditionally been the domain of majoritarian males. Curricula should embed high-quality, cognitively rich formative assessment within class materials. The CCSS Mathematics Curriculum Materials Analysis Project advises reviewers to carefully consider the ways that formative assessment is used in the curriculum. Not all technological resources are created equally. Curricula should support rich, appropriate use of digital resources and extend and support student learning. I revisited the curriculum materials as I addressed the questions in Tool 3. The rubric describes the extent to which the materials provide teacher support in these three critical overarching considerations. I considered the ancillary support materials in addition to the teacher and student text for this tool. At the end of Tool 3, I summarized my responses to determine the degree to which these issues were addressed in the curriculum materials. Particular strengths of the equity component include the following. CPM provides excellent support for teachers who wish to use collaborative teaching practices. Researchers have found that some students of color perform better in classrooms where collaboration versus competition is encouraged. These findings were from Thompson et al. In 2004. Furthermore, in addition to cueing teachers to have students solve problems in teams, the curriculum also provides extensive structures for developing team norms, roles, and gambits to help manage students' teamwork. There are also self and peer evaluations to accompany collaborative tasks and detailed suggestions to structure and encourage student discourse. One of the weaknesses of the equity component that I found was that the limits of the Core Connection series have to do with the lack of specific supports for ELL students. There's a substantial use of racial inclusivity, but there's no effort to include transgender or non-binary students. The main opportunity for advanced learners is to enter problems at later points that omit some of the scaffolding or to do extra work that takes them out of the text and into the ancillaries. This is adequate, but not exceptional. Regarding the assessment component, one of the strengths is that CPM provides an astonishing array of assessment supports for teachers and opportunities for students to learn from their mistakes and strengthen their understanding as content spirals throughout the year. The potential weaknesses of the program are that teachers may be overwhelmed by the options available and may over-assign problems on tests that become too long and too complicated to be effective. Though the assessment handbook cautions against this, the handbook is an ancillary that teachers must read separately from the problem bank and is not always accomplished. Regarding the technology component, one of the strengths is that there's a lot of support for teachers that would like to incorporate meaningful technology into their classrooms using the www.cpm.org website. During COVID-19 pandemic, CPM also added virtual teaching supports to their program. One of the weaknesses of the technology components is that teachers must be motivated to incorporate technology for students to benefit from this component. There's not a developed management system to support synchronous collaboration, so these types of activities are limited by classroom activities rather than truly interactive components. On this slide, I show an excerpt from the Tool 3 analysis. I completed the analysis using Tool 3 by considering the student and teacher texts as well as the ancillary text resources. This excerpt considers the extent to which CPM supports equitable teaching practices. The curriculum indeed offers many supports for teaching and learning. Between student and parent ancillaries and structured collaboration, there's ample student support at all levels. Furthermore, there are daily prompts for teachers to use self-reflection, peer dialogue, and individual remediation and extension to support students as they move from their entry level to mastery. CPM offers very structured guidance on forming flexible groups for many purposes. There's heavy scaffolding throughout classwork and homework problem sets. Teachers can have students start at different places if needed as well. CPM offers student-parent support online in English and in Spanish, but not in any other languages. The strategies they include are effective to support ELL students, but are not necessarily ELL specific. The following policy considerations should be made if a district is choosing to implement the CPM Core Connections ALgebra series. First of all, it's an excellent curriculum, but it's costly to implement. When deciding whether to adopt the CPM Core Connections ALgebra curriculum, districts and schools need to be prepared to invest heavily in teacher professional development and student manipulatives. The success of the program depends on teachers understanding how to use mathematical models and how to teach using questioning without telling. This is a major change for many teachers and has been a barrier to the success of many inquiry-based programs, according to Rudolph, 2019. Success depends on the faithful implementation of collaborative learning strategies. CPM offers support for structuring student teams to provide mutual interdependence and accountability. However, teachers unaccustomed to working with collaborative groups or teaching students that have not learned in structured groups previously may be uncomfortable with the learning curve associated with a team-oriented classroom. If teachers merely assign students to work in groups without providing training and the consistent emphasis on behavior expectations, they may retreat from the chaos that could ensue during the training process. Principals and district personnel must understand what to look for when visiting classrooms. When evaluators visit a CPM classroom, they must expect teachers to be a guide on the side as opposed to the sage on the stage. This means they are likely to see a workshop model that relies on productive struggle and persistent questioning by the teacher. Students are often uncomfortable in being made to endure in solving problems without a teacher coming to the rescue. It can be uncomfortable to watch a student struggle if one is not expecting the teacher to be firm in avoiding telling behavior. This implies administrators and district personnel should be trained in CPM methodology as well as teachers. For example, CPM encourages teachers to enforce a 3 before me policy, meaning that every team member in a group of 4 must have the same question before raising a hand for help. That means if one student is stuck, they should turn first to their 3 teammates before seeking the teacher's help. This is just one sort of specific strategy used in CPM that if district personnel and administrators are not schooled in, they might not recognize when visiting classrooms. Last but not least, be prepared for productive noise. A CPM classroom is noisy. Students are encouraged to explain to a partner, share in their groups, use conflict resolution strategies that include active listening and clarifying reasoning. They may move about the classroom to make use of different manipulatives and resources like laptops and whiteboards. That said, I highly recommend the CPM curriculum for adoption. Thank you very much for attending this presentation. The references that I've made during this presentation are listed here. Thank you and have a good day.